Finding the resultant vector graphically is basically just taking the picture that you have and scaling it, stretching it, or shrinking it, or reversing it in the specified value. So for example, if I had vector v here and I wanted you to graph 1/2 of vector v, it basically means here's my vector v, I just want half the length, so my answer would be just this. Okay. Conversely, if I had something like this means I'm going to take vector v and I'm going to duplicate it twice, so my final answer stretches from here all the way to here. So my final answer would be twice as long in that same direction as vector v. If I had negative vector v here, that just means instead of going in this direction, I'm going to duplicate it, but going in the opposite direction. So there is a sketch of negative vector v. And the sum and difference basically means if I want to combine the two. So if I had v plus w, that means if I followed vector v, and then from this point create vector w, which means duplicate vector w, which looks something like this, my final answer after everything is said and done would start from here at the very beginning to the very end here. So my resultant vector looks like this. Okay. There's also something called a parallelogram method where you can sort of create a parallelogram with original vectors v and w, and then create that diagonal as your final resultant answer.